Alright, ready, steady, and a goey. Hello, everybody. My name is Andres Menjivar Jr., and this is my final project for COMP435 Computer Security Concepts. Let's cue the music and get started. Alrighty, now that it's daytime, today we're going to be covering one of Microsoft's latest security vulnerabilities, CVE-2020-1472, otherwise known as Netlogon or Zero Logon. So, what is this attack? So, Netlogon is an elevation of privilege vulnerability. What this does is that it allows for hackers to run any program on a device within an access domain controller. It can also be considered a foot in the door attack because once an adversary has a conversation or connection between themselves and a domain controller, this attack can become executable. So, how bad is this? Well, when we relate it back to the course, this can be considered a major threat as hackers have this ability to self-authenticate themselves into a server, leading to a major breach, especially regarding any personal information. And due to the simplicity of this approach, it has the most concerning severity rating in Microsoft's history. So, before we actually go into the attack itself, let's actually go over some quick terminology. So, our first term is going to be a Netlogon Remote Protocol, MS-NRPC. This is a remote protocol interface that's used for authenticating Windows users into domain-based networks. This usually maintains relationships between members of a domain and the domain controller. It can also maintain relationships between multiple domain controllers across one or multiple domains, as well as replicate any domain controller databases. Now, the next term that we're going to be going over is a transmission control protocol. Now, this is that connection or conversation that I brought up earlier, but this creates a connection to have a conversation between yourself and the server, and it's usually used for any data transferring. Now, for this attack to work, essentially you have to create a connection with a vulnerable domain controller. And once you do that, you can go ahead and start scheming. Now, the last term that we're going to go over is our encryption process. This is AES CFB8, which is an 8-byte cipher feedback. This takes an 8-byte input and performs a transformation on it with a randomized initial vector, and then produces a ciphertext of equal length. Now, our general assumptions are that an attacker that does not know this initial vector will not be able to calculate or guess the correct matching output with the specified certain input. And this allows for this initial vector to be a form of session key or authentication on the user's behalf. Now, the issue with this attack, or the issue with this authentication system, is the misusage of this encryption process. So let's go over how it works. So the first thing we do is that we provide an 8-byte plaintext input. And afterwards, the system will randomly generate an initial vector, which will be used as a session key. And then once we do that, we'll prepend this initial vector to our plaintext. Now, once we have done this, we're going to go ahead and run this initial vector through an encryption process, through the AES encryption, and we collect our first byte. We XOR the first byte of the encryption to our first byte of plaintext to get the first byte of our resulting ciphertext. We then replace our first byte plaintext with the first byte ciphertext. Now, once we've done this, we're now going to select the next 16 bytes. Now, the 16 bytes are now going to be 15 from our initial vector, and then the one newly produced cipher byte from the last step. Now, when we run this through the AES encryption, we again take the first resulting byte, and we XOR that with the plaintext of the second byte. And then after that, we get the result, and we replace our plaintext with the new ciphertext byte. And we continue this process up until the point that we've encrypted the entire plaintext message. So, as I mentioned, this process is being misused specifically with a ComputeNet logon credential. And what this does is that it restricts the length of our initial vector by default. Now, due to this restriction of 16 bytes, say you provide an all zero input, you have a 1 in 256 chance of getting an all zero output to be your form of authenticating. And the issue with this is that assume the attacker gets this 1 in 256 that takes approximately 3 minutes to produce, they know that the session key is also going to be composed of all zeros. Now, luckily, besides this, no political or social information is really needed to understand this attack, and regarding procedural information, As I mentioned, it's a foot in the door attack at first, because once you establish this connection with domain controller, the attack can begin, and later on we'll see how this is an elevation of privilege attack. So let's start going over our attack vector. Step 1, a breach. The attacker must begin by creating a TCP connection with a domain controller. After they create this connection with a vulnerable domain controller, they have to authenticate themselves. Now, by default, the server calls a net server authenticate 3, which takes in a client credential. Now, this client credential is composed of calling the net compute logon credential, which will take in the input of the user and encrypt it. Now, as we mentioned, essentially because of this restriction, the compute net logon credential will end up producing an all zero value in 1 in 256 chances, assuming that the user provides an all zero input. And this will end up making our client credential as well all zeros. Now at this point, because we successfully essentially predicted the session key and determined what it is, we can authenticate ourselves in a server as any person within this domain. So for this example, let's go ahead and say that we have authenticated ourselves to be user Bob. So Bob has entered the stage. We're finally in. We're able to authenticate ourselves. Nice. But let's go ahead and make a function call. Now, in order to do this, we actually have to provide an authenticator value. So the authenticator value is composed of 4 things: the compute net logon credential, a session key, a client stored credential, as well as a timestamp. Now, because we were able to authenticate ourselves successfully, we know that compute net logon credential as well as our session key are going to be all zeros. Now, our client store credential is actually an incrementing value that starts at 0 the moment of this call. So we can go ahead and ignore that for this case. Now, our timestamp is what's interesting, because in this scenario, we're actually able to select a timestamp of our choice. So what attackers normally do is that they'll select a timestamp of January 1st, 1970, which will give you a returning value of 0. So once we've essentially done this, we have provided an authenticator value of 0 for this user, and we can successfully make this function call. So at this point, we're not really Bob. We're just an all 0 authenticated user, and we can change the password by simply providing a block of data of which contains an all 0 password or even a complex password if we choose to do so. In either case, Bob, our old user, is now blocked from accessing this domain, thus a successful attack. But is this enough? So this is where the elevation of privilege attack comes into play. In worst case scenario, essentially, the attacker changes information of everyone up to the point where they're able to essentially detect the admin of the domain controller and change their information and then impersonate them. At this point, the attacker can actually run a secret dump script, and they can choose a password of choice. And what's going to happen is that the domain controller is going to update, but it will behave as normal, but it will end up making the attacker an admin. Now, though no financial losses were ever made public in regards to this attack, it was greatly expressed that the worst case scenario was probably most costly. Now, of course, once this was discovered, Microsoft eventually created a quick patch, but there was a large extent of who was really affected by this. It was really ranged from 2008 servers to 2019 servers, and it really spread like wildfire in regards to this patch, where the United States Cybersecurity and Infrastructure Agency requested that all of their workers do it immediately, which really showed the potential harm of this attack. Now, as I mentioned, Microsoft released part 1 of this patch in August, and they plan to release part 2 sometime around February 1st quarter next year. Anyone who has not updated this patch, even someone viewing this, I highly recommend that you download an update if you've not since August, just because someone does have the potential to essentially block you out of your own computer. So, some key takeaways from this that I'd like to mention is that really, no matter how difficult a system is set up or the reputation of the creators, in this case being Microsoft, any system really has its flaws. And also, do take note of the potential danger. This was really an Achilles heel, which led to Microsoft doing a 2-part patch, one being very immediate, the other one waiting up to a few months for it to come out within first quarter next year. So at this point, we've actually reached the end of the presentation. This is my works cites page. For anyone who's reached up to this point, thank you very much. And of course, our very last thing for today is going to be questions for the crowd. My first question for you is going to be, how is AES encryption being misused for authentication? And my last question for you is going to be, in your own words, describe what an adversary is doing to the server and its authentication process. At this point, I bid you all farewell and thank you much for watching. Thank you.